Python loops are everywhere, but small mistakes can quickly turn simple code into a mess. In this video, we will fix that with 13 real examples you can use in scripts, interviews, and everyday Python projects. We will start with everyday loops you use in scripts all the time: printing lists, filtering records, and adding totals from structured data. When a command line tool shows tasks, file names, or menu choices, plain list printing is usually too messy. Here we write a small loop with enumerate, so Python gives us both the position and the task name. Now we run the script and check that the terminal prints a clean numbered list. Let's break down why this works. The loop receives two values each time, the visible number and the actual task text. Setting start to 1 makes the output match how people count in menus and reports. Now we show the cleaner habit to keep. Use enumerate when you need both the item and its number, because it avoids a separate counter variable and keeps the loop focused on the real work. Real apps often receive a list of user records, but only some users should get a notification. Here we create user dictionaries, loop through them, and append only emails from active accounts. Now we run the script and the terminal should exclude the inactive user. Let's break down the result. The if statement is the gatekeeper inside the loop. Maya and Noah pass the condition, Leo does not, so only 2 email addresses are printed. Now we show the naming habit that makes this loop easier to maintain. The output list is called active emails, so anyone reading the code knows exactly what the loop is collecting. Use explicit conditions and specific collection names when filtering data. A common backend task is adding amounts from orders returned by an API or a database query. Here we create a few order records, start total revenue at 0, and add each amount inside the loop. Now we run the script and watch each processed order plus the final total. Let's break down the accumulation. Total revenue keeps the running result between loop iterations. After the last order, it contains the sum of all amounts, so the final line prints the revenue total. Now we show the cleaner structure for accumulator loops. Put the accumulator right before the loop and give it a business name like total revenue. That makes it obvious what number the loop is building. Next, we control when a loop should stop and when it should skip bad data, which is where real-world loops become much cleaner. When searching records, continuing after the match is wasted work. Here we scan product dictionaries by SKU, save the matching product, and use break as soon as we find it. Now we run the script and confirm that the loop stops before checking the USB hub. Let's break down the flow. The loop checks the keyboard first, then the mouse. When the SKU matches, Python stores that product, and break exits the loop immediately, so there is no extra scanning. Now we show the best rule for early exits. Use break when the answer is final and later items cannot improve it. This keeps search loops faster and makes your intent clear. Imported CSV-like data is often incomplete and deeply nested if statements make processing hard to read. Here we use continue as a guard clause. First skip rows with no email, then skip rows with no amount, and only then process the valid row. Now we run the script and see exactly which rows were skipped and which were processed. Let's break down the control flow. When a row is invalid, continue sends Python straight to the next row. That means the successful processing line stays at the normal indentation level and is easier to scan. Now we show the best pattern for messy imported data. Use early continue statements for invalid cases so the main success path stays simple. Apply this when bad rows should be ignored, logged, and then skipped. Now we move from simple looping into building useful data structures. These examples are about taking real program data and reshaping it so the rest of the code becomes cleaner. When an API sends data into your app, you usually do not want the rest of the program, depending on those raw field names. Here we write a loop that prints the raw records first, then builds a clean list with normalized keys and values. Now we run the script and compare both shapes in the terminal. Let's break down why this is useful. The raw records still have API-style names like customer ID and email address, but the cleaned records use the names the app actually wants. The loop also removes extra spaces from names and normalizes emails so later code does not repeat that cleanup. Now I am showing the best practice because this pattern keeps real projects easier to maintain. Treat external data as input, then convert it into your own internal shape at the edge of the program. That way, if the API changes later, you update one transformation instead of hunting through the whole codebase. In logs, you often need a quick summary instead of reading every event one by one. Here we loop through event dictionaries, pull out the level, and count how many times each level appears. Now we run it and check that the summary is compact. Let's break down the counting line. If info is already in the dictionary, we read its current count and add 1. If it is not there yet, get gives us 0. So the first info becomes 1 instead of. Now I am showing the best practice because Python has a tool for this exact job. If you are only counting values, collections. Counter is usually clearer and shorter. Use the manual dictionary version when you need custom rules while counting. These sales reports often need one answer. Which product performed best? Here we keep a tracking variable called best_product and update it only when the current product has more sales. Now we run the script and watch each comparison happen. Let's break down the result. Keyboard becomes the first winner because there is nothing to compare against yet. Mouse replaces it, monitor is skipped, and USB-C hub becomes the final winner because 64 is the highest sales value. Now I am showing the best practice because real production code can often be shorter here. For a plain maximum search, max with a key function is clear and Pythonic. Still, understanding the loop version helps when your comparison logic becomes more detailed. This section is about looping over related inputs at the same time. The goal is to avoid index-heavy code when the values already belong together. Reports often start with separate lists, but each name belongs to one score. Instead of looping over indexes, we use zip, so every iteration gives us the matching name and score together. Now we run it and check that every report line lines up correctly. Let's break down what zip is doing. On the first loop, it gives Nora and 92. On the second loop, it gives Ethan and 68, so the values stay paired without us touching list indexes. Now I'm showing the best practice because this is where many messy loops come from. If you need values from multiple lists at the same time, use zip instead of range and indexes. It makes the relationship between the inputs visible in the loop itself. The last section in this batch uses loops to control real workflow behavior. Instead of only processing data, the loop decides when to keep trying and when to stop. Network calls can fail temporarily, so retry loops are common in automation code. Here we simulate an operation that fails twice, succeeds on the third attempt, and stops immediately after success. Now we run it and make sure there is no final failure message. Let's break down the control flow. Attempts 1 and 2 fail, so continue skips the rest of that loop cycle and moves forward. Attempt 3 succeeds, break exits the loop, and because break happened, the else block does not run. Now I am showing the best practice because retry loops can become dangerous if they run forever. Always set a clear maximum attempt count and make the success condition obvious. In real network code, you would also add a short delay between attempts. In this section, we use loops to control real workflows instead of just repeating toy examples. When you upload files, send emails, or process database records, batching keeps the workload controlled. Let's create a list of file names, choose a batch size of 3, and use range with a step to jump through the list. Now we run the script and the terminal shows each batch, including the smaller final batch. Let's break down why this works. The loop starts at 0, then moves to 3, then 6, because batch awk size is the step. Python slicing does not crash when the end goes past the list length, so the final batch simply contains the remaining files. Now let's show the best practice. Keep the batch size in a named variable because production limits change often. If an API allows 10 files per request today and 20 tomorrow, you update one value instead of rewriting the loop. For practice, change the batch size to 2, then to 4. Before running the code, predict which file names will appear in the final batch. This trains you to reason about range steps and list slices together. In this section, nested loops stay readable by using clear names and structured records. Nested data shows up everywhere in real code, especially in orders, invoices, and API responses. Here, each order has customer information plus a list of products, so we use one loop for orders and one loop for products. Now we run it and see one flat record for every product in every order. Let's break down the result. The outer loop gives us order-level data like order ID and customer. The inner loop gives us one product at a time, and each output dictionary combines both levels into a single record. Now let's show the best practice. Use names that describe the level of the data: order for the outer object, product for the nested object, and line item for the result. This makes the loop explain itself while you read it. For practice, add a price to each product and calculate a subtotal field. Keep the same nested loop, but build a richer flat record. This is the same pattern you would use before exporting order data to a report. In this section, we use loops and patterns that matter when the input can be large. In production, log files can be much larger than the memory you want to spend on them. Let's create a sample log file, open it, and loop over the file object directly so Python gives us one line at a time. Now we run the script and the terminal shows a compact error summary. Let's break down why this pattern scales. The loop does not build a giant list of lines. It checks each line, updates a counter, and only keeps the small sample we want to print later. Now let's show the best practice. When a file may be large, iterate over it directly and store only the summary you need. This pattern is useful for logs, CSV imports, audit trails, and any text file that can grow over time. For practice, collect the first 3 error lines instead of 2, then add a warning counter. Keep the file streaming loop the same because the goal is to add more summary logic without loading the whole file. Now you have 13 practical loop patterns that can make your Python code cleaner and easier to understand. Like the video, subscribe to Dev Level Up, and write in the comments which Python topic you want to see next.